In this video, I am going to solve the problem 29 from chapter 19. The volume of an ideal gas is adiabatically reduced from 350 liter to 130 liter. The initial pressure and the temperature are 2 atm and 380 Kelvin. The final pressure is 8 atm. First question, is the gas monatomic, diatomic or polyatomic? Second question, what is the final temperature? And the third question is, how many moles are in the gas? So we have to answer for this question one by one, and before that we have to write what is given in the question. So here the thermodynamic process they mentioned here as adiabatic process, and here by this adiabatic process the volume information is given. So that means the volume reduced from 350 liter to 130 liters. That means the initial volume here is 350 liter and the final volume is 130 liter. And likewise its pressure information is also given. So pressure initial value here is 2 atm and the initial temperature is also mentioned here, which is Ti, takes the value of 380 Kelvin. And also they gave the information about the final pressure, which is 8 atm. So now we have to answer whether the gas is monatomic, diatomic or polyatomic. And also in the second part we are going to find what should be its final temperature. So for this, for the first two questions, what I am going to do, I am going to write the relation, two relations, which is very important for this adiabatic reaction. Clear? So for the adiabatic process we have to use these two equations. So what are they? The first one, the pressure relates with volume. Pi Vi gamma, which is equal to Pf Vf gamma. This is the first relation which relates pressure with volume. What is the second one? Here we are going to use the relation, the temperature relates with volume, that is Pi Vi gamma minus 1, which is equal to Tf Vf gamma minus 1. So if you use this relation, we are going to find the answer for the second question. But now I'm going to use the first one for getting the information about the gas, whether it is monatomic, diatomic or polyatomic. So first of all, I'm going to use the first equation. So what I'm going to do, in this equation, I'm going to separate the pressure one side and volume one side. So likewise, what I'm going to do, I'm going to take the volume V final gamma to the left hand side. By that, this equation will become Vi gamma over Vf gamma, which is equal to P final over P initial, right? Okay. Now what I am going to do, I am going to apply the natural log on both sides. So if you apply natural log on both sides, how you can write? Also one more step I'm going to write. So here the gamma, both Vi and V final have the gamma as a power. So we can write this relation as Pf over Pi, which is equal to Vi over Vf whole power gamma, right? We can write like this. Now what I am going to do, I am going to apply the natural log on both sides. By that, the above expression will become natural log of Pf over Pi, which is equal to the natural log of Vi over Vf the whole power gamma, right? Okay. Now by applying the logarithmic rule, how we can write this term? We can write the right hand side of the term like we can take the power to the front. So how we can write gamma of natural log of Vi over Vf. Left hand side term I'm going to write as it is. So ln of Pf over Pi. Now what I'm going to do, for getting the information about the gas detail, I'm going to identify the value for this gamma. So I have to rearrange this equation in terms of gamma. By that, this equation, the above equation will become gamma equal to natural log of Pf over Pi over natural log of Vi over Vf, right? Now we have all the information in the question. We have the information about the final pressure, initial volume, and final volume. We have every information here. So now what I'm going to do, I'm going to substitute the value here. If you substitute, what will happen? The gamma, this equation will become gamma equal to natural log of, what is the value of PF, which is 8 atm, right? You have to see here. PF is 8 atm and PI is 2 atm and VI is 350 liters and V final is 130 liters. So I'm going to use these details here. Clear? Okay. So therefore gamma equal to natural log of, I'm going to substitute the value of PF. What is the value of PF? 8 atm over, and PI is 2 atm divided by natural log of VI, takes the value of 350 liters over, and VF is 130 liter. Now if you calculate this, we will get the answer for the gamma is exactly 1.4. What this 1.4 exactly stands for? So this gamma stands for the Cp over Cv, right? Okay, let's just use the rule for cross-checking our answer. What is the rule for gamma? Cp over Cv. So if you take the diatomic value for Cp is 7 over 2 times of R, and Cv takes the value of 5 over 2 times of R, right? And if you substitute, what will happen? We will get the answer here as 7 over 2 times R over 5 over 2 times R. We can cancel this, and if you cancel this, we will get 7 over 5, which is equal to 1.5. That means here we use the information about the Cp and Cv as a diatomic molecule. Am I right? So diatomic gas information we are substituting here. So here we got the answer here as 1.4, right? So we got 1.4, and here also we got the answer as 1.4. So that means this gas is a diatomic gas. So what is the answer for the first question? The gas is diatomic, or it is a diatomic gas. So the answer for the first question is it is a diatomic gas. Clear? Okay. Now we have to answer the second question. So what is the second question? So better I can write. We are going to find what is its final temperature. So I'm going to use this relation. So better I can make a separation here. So I'm going to use this relation. So now I have to rearrange this equation in terms of, so that means we come for the part B. So I have to rearrange this equation in terms of TF. So therefore TF is equal to T initial VI gamma minus 1 over V final gamma minus 1. Now we can rewrite this equation as TI VI over VF the whole power gamma minus 1, right? Now I'm going to substitute the value. We already know the initial temperature as 380, so I'm going to substitute the value here for finding the answer for TF. So TF here is 380 Kelvin, and VI value here is 350 liters, right? 350 and 130 liters, and V final is 130 liters, and the gamma, just before we found in the first part, the gamma takes the value of 1.4, so 1.4 minus 1. So if we calculate, I got the answer here as 564.72. Clear? Anyhow, I will cross check one more time. 380 multiply with 350 over 130 power 1.4 minus 1, here is 0.4. Yes, the answer is right. So the unit for this TF is Kelvin. So 564.72 Kelvin. So this is the answer for the second part. Now we have to answer for the third part, how many moles are in the gas. So here we can use the ideal gas. What is the ideal gas equation? As we already know the equation for the ideal gas, which is PV equal to nRT. So now you can use for anyone for the initial condition or final condition. So now I am going to use this equation for the initial condition. PI VI equal to N or TI. You can use like this also. Or if you want to use the final condition, no problem, you'll get the same answer. But anyhow, I will just show the answer for both. So PF VF, which is equal to N or TF. You'll get the answer for both as the same answer. Either you can use the first part or the second part. Initial condition and final condition will give the number of moles as the same value. So now I am going to rearrange this equation in terms of number of moles. Therefore, N equal to PI VI over TI. Clear? And likewise here, N equal to PF VF over TF. Right? Okay. Now I'm going to substitute the value. You know the initial pressure. So I have to convert this pressure in terms of Pascal. So here our initial pressure here is 2 atm and 8 atm. So I can just convert 2 multiply with 1.01 multiply 10 power 5 multiply with our initial volume here is, I think it's 350 liters, right? So 350 liter over our initial temperature here is 380 Kelvin, which is already given in the question. So I have to find the answer for the number of moles for the initial condition. So I have to calculate 2 multiply 1.01 10 power 5 multiply with 350 over. Also, I forgot one more term, right? I have to multiply with the gas constant, which is 8. I have to write the gas constant here, right? 8.314. So 380 multiply with 8.314. I got the answer here as 22378.2 moles. Clear? So I can write these as 2.24 10 power 4 mole. If you use the second part, again you will get the same answer. So let's try for this also. Our P final value, which is 8 atm, which is 8 multiply 1.01 multiplied by 10 power 5 for converting into Pascal, and our V final value here is, I think it's 130, right? Yeah, 130. 130 over the gas constant is 8.314 multiplied with the final temperature, because just before we found the answer for the final temperature here as 564.72. So I'm going to use that value 564.72. Let's see whether we will get the same answer or not. So N equal to, let's see whether, so 8 multiply 1.01 10 power 5 multiply with 130 over 8.314 multiply with 564.72. Yes, got the same answer as 2237.2.3 moles. So if I just write in terms of power, we can get 2.24 multiply 10 power 4 mole. So that means either you can use the initial condition or final condition, you will get the same answer, right? So this is the answer. So I just prove for both the initial and the final. That means our answer is right. Clear? That's it. So we already answered for 3 questions here. Thank you.